Hi, welcome to EGR 325. This is Introduction to Electrical Circuits, and I don't know, I'm teaching a lot of classes with electrical circuits this semester, so I don't remember what the name is. I should probably look that up. It's Introduction to Electronics and Electrical Circuits. There we go. What a day to start the semester. Awesome. Well, my name is Dr. Cale Stoley. I am the professor teaching this course. A little bit about me. I'm a human. So, that's about it. That's all you need to know. I have credentials, I promise. I'm not some random guy who walked in off the street and was like, hey, I'm going to teach people about electronics. Yeah. What we're going to do today is, this is supposed to be a 2.5 hour long class. It is against everything I believe in to post a 2.5 hour long video, because that sounds like 3 different flavors of hell. So let's not do that. Instead, I'm going to be posting 3 roughly half-hour videos today and on Thursday. A total of 6 videos this week. And my goal for that is not to make you die. It's only to make you suffer on the inside, just a little. And that's it. Without dying. I don't want to bring you all the way to the brink. So, that's my goal. 8 o'clock in the morning classes are hard for me because I am not a morning person. I saw the sunrise this morning and thought to myself, that happened. Okay. Before we get started in this class, I actually want to take a step back. All of you who are in this class have seen a very interesting side of college. For the past year, we've been dealing with coronavirus restrictions. We have had quarantines. We've had times when you were locked out of the school. We're sitting in a place where your class has really experienced a very unique experience in higher education. The fact that you're still here shows a lot of resilience. And even more than that, in order to get into this class, you had to have taken at least Calculus, Physics 1, and Physics 2. You had to have passed all of those classes just to be in this class. Being in this class is a sign that you have put in a lot of effort as a student to get to this point. This isn't something where you just accidentally wandered into this class and now some guy who wandered off the street is going to teach you electrical circuits. You had to work to get to this point. You come into this class already having proven that you are intelligent. Okay? You cannot get to this point without being smart. You can't. So, for me to treat you any differently than as an intelligent intellectual would kind of be a disservice to you. Now, that does come with a disclaimer. I am going to treat you like an intellectual, but I'm going to make this class very challenging. Because that is something that an intellectual would deserve. My goal for this class is not to be your best friend. If you've taken a class with me before, I tend to be a very off-the-cuff guy. I say dumb things. And that's great when you're a freshman. When you're a freshman, I have no expectations of you. You can walk in off the street and take my freshman level classes. They are the easiest classes I teach. This is not one of the easiest classes I teach. If you've talk to anybody about this class, I teach this class like it's a challenge, because it should be. This is a 4 credit hour class. It's a class that builds on substantial knowledge that you gained in Physics 2 especially. And it's a class that really should be opening your eyes to how circuits work. A lot of engineers, young engineers in school, will sit down and say, why am I taking physics? Well, I was one of those students taking that. A lot of the concepts that we brought about in physics in my education didn't get used in my engineering classes. It was just fun physics stuff to learn. We try not to do that here at Doane. We try to make sure that everything you learn is valuable, so that when you walk out of here you feel empowered to make decisions and understand the world around you. And part of this electrical circuits and electronics course is not just to teach you, everybody likes using Ohm's law, V equals IR. It's not just, hey, we're going to play with that formula all year, which we are going to play with that formula, but that's a different story. It's not just to play with that formula, it's to really understand how to make a circuit work. Okay, circuits are both really incredibly complex and very incredibly simple. Once you understand the base concepts, they're very simple. The base concepts themselves are incredibly complex. And that's part of what makes this class so challenging. I am going to expect you to understand this. It doesn't matter if you are civil engineering emphasis, doesn't matter if you're environmental engineering emphasis, mechanical engineering emphasis. This is all material you need to know. The world is getting smarter. The world is getting stronger and more powerful. There are AI-driven systems everywhere. IoT has really become a very useful tool for how to control systems. We live in a world where we will only get more intelligent and continue to design more intelligent systems. And you need to be able to understand just the fundamentals of how those are constructed and how to make them work, all of that. And that's really what this course is. This course is not trying to teach you how to build your own computer. There is a course for that, but that's not this one. This course is intended to give you foundational knowledge to be able to build electronic devices yourself. Okay? More than that, we're going to be using these little puppies in class. This is a Raspberry Pi. This is one of my favorite toys in the world. But we will be using that in class, and the way we are going to be using that device is not just to engage the hardware side, look, I built a light. It's also to engage the software side. Look, I built a program that controls a light. Okay, and that's where we're sitting. The purpose of this class is to give you foundational knowledge, which means I'm going to be kicking your butt all year long. I have a lot of students who, as freshmen, come to me and say, there's no way I could be as smart as this junior. And that's not true. This semester is a defining semester for most of you, because most of you come into this semester having taken a lot of very, very hard classes. And now, having taken a lot of hard classes, this is where we start getting into the meat of where engineering becomes real. And that is by design. That's the way this course is designed. It's the way that this entire program is designed. After this semester, you should be able to engage simple engineering principles, design principles, analytical principles on very complex things. That should be what you'd be able to do. And you're going to be amazed to look back on how this year has changed you. You will not be able to get through this class without growing substantially. In order to be successful in this class, you have to work hard. You have to hand in your homework. You have to pay attention in lectures. You have to listen intently, take notes. If you don't take notes, you will not be successful. There are exams in this class. If you know me, I hate exams. I hate them. But I put them in this class because it is important that you be able to critically engage the material on that level. I don't like to give exams, but exams force students to do some memorization, to focus on what's really important about a topic. And that is going to make this class harder. And I'm okay with that. I'm okay with this class being hard. You want to succeed in this class, though, you turn in your homework, you pay attention, you take notes. Okay? You got to treat this seriously. This isn't a class where we can make fart jokes and, well, actually, yeah, I'm probably going to do that anyways. Dang, now I got derailed. Let's go over the syllabus. All right, so I will transition here, bring up the syllabus. So I use Streamlabs. So this is EGR 325, Physics 325, and IST 325. I didn't put IST 325 on here because I don't. Stop asking questions. You're supposed to question your professors. Just take everything I say, just believe it. I didn't put my office hours on here yet. I still have some commitments that I have to figure out on my end. But more than likely, I will be available right after this class. I will not be available right before this class. Unless you want to hear a very angry middle-aged man tell you about how much he hates mornings. This class goes from 8 o'clock to 10:30 in lead 233. I will try to use most of that time. It's hard to sit in a class for 2.5 hours. I know. I don't sit still that long either. But I do give breaks in that class. And we do try to do some hands-on stuff. Working with the Raspberry Pis kind of breaks up the monotony. Again, this is a 4 credit hour class. Here's the textbooks that we're using. I don't know where my textbook is, so just imagine I'm holding a picture of the textbook, and that's what it looks like. I am also going to be asking you to purchase Raspberry Pi this semester. Now, it is not absolutely required, but you're going to at least have to be working with somebody who owns one. And having a Raspberry Pi is going to make everything easier, because otherwise you have to use, we're going to be programming in Python, and we're going to be connecting circuits, and if you don't have a Raspberry Pi, it's just going to make it that much harder. Plus, learning Raspberry Pi is awesome. But I will provide those details this week, and we will begin using Raspberry Pis about the first week of February. So, the overview of the course, it's intended to provide an introduction to circuits, electronics, and electrical components, how they work, how to calculate them, how to analyze them. You will be constructing some circuits yourself, and you will be understanding how to build circuits such as power supplies. We're going to be talking about both DC and AC circuits. There's a lot of content that we have in this class, and at some point it will require some differential equations, which gets really fun really fast. So, the 5 course objectives that I really have for this course is I want you to be able to model physical circuits as electrical circuit diagrams. I want you to be able to understand physical circuits in that way. I want you to be able to construct basic analog and digital circuits. Okay, we'll talk about what that means. I want you to be able to use your analytical knowledge to assess current and voltage through different components and complex circuits. I want you to be able to use Raspberry Pi and be able to integrate that in. Raspberry Pi offers a lot of interesting control mechanisms. They are themselves, despite being computers, they're also microcontrollers. And then I want you to be able to calculate power. I love talking about power. We're going to be talking about power today. Okay. Most of this course is going to be taught in person. With quarantine restrictions, that does make that harder. This is a lab-based course, though, and the challenge with a lab-based course is that you can't teach it online very well. A lot of you have probably had online lab classes. I hate teaching online. YouTube videos are fun, and it's awesome that you can go back and re-watch this video and pick up on some of the dumb things I'm doing, or pick up on the little minute details. That's great. But I do not like this format because it's very impersonal, and it's hard for me to monitor your progress. So if you do enjoy online classes, unfortunately this is not the class for you. This has to be done in person. I like standing in front of people and yelling, rather than standing in front of a camera and yelling. It's just not the same. I mean, cameras don't have feelings. I can't break a camera's heart, but I can break a student's heart. Boy, throwing all of this on the internet, that's great. Will be forever emblazoned as my legacy. I like breaking students' hearts. So for coursework for this class, there are a lot of different modalities of homework that I'm going to be applying to you. Again, this is a hard class. This isn't a class that you can just skate by. I'm going to be giving you quizzes, reading assignments, homework assignments, exams, and 2 projects. There's going to be a lot of work associated with this. I know that this has been a hard year for all of you, not just for COVID, but because this is how our curriculum is set up. This doesn't get easier now. This is the point where I expect you to be an intellectual. And all of you have proven yourselves as intellectuals, so I feel like I can. I want this to be worth your time. So it's going to be hard, okay? Now the idea is I'm going to be assigning homework on Tuesdays. It's going to be due on the next Tuesday, okay? I'm not going to give you homework and have it due Thursday. That's weird. I might extend a due date. I might give you a project deadline of Thursday, but ultimately everything is going to be due Tuesday. I have weekly homework. I do not have daily homework. Daily homework drives me nuts. Also, I hate grading, so that drives me extra nuts. Okay. I do have a format for how I want homework and reading assignments to be done. Your homework, don't put more than 2 problems on the same page. If you try to cram in 8 problems on a single page, I don't care what problems they are, it looks awful. As engineers, being able to organize your work so that your work can be read is a struggle you will face your whole life. Some people can do it naturally. I am not one of those people. I had to learn this skill, and one of the things that I had to learn about it was, first of all, I had to learn how not to conserve engineering paper, because that's how I was raised. But you need to also learn how to space out your work, how to make it readable, how to make it followable, okay? So that you can look back through it and use it as useful tools when you go to understand how you did a problem. Okay, so no more than 2 problems on a page has to be done in engineering paper, and I am requiring students to scan in their homework and post it on Canvas. Okay, it's got to be in PDF format. I won't take it any other way. So, yes, that's a lot to ask. Yes, that does make handing in your homework a challenge. But at the same time, you just have to. That's how this class works. Okay. Similarly, reading assignments, you have to handwrite them and scan them in. For the first few weeks, if you hand in a typed assignment, I will tell you, no, don't do that. I said to handwrite them. After that, I won't even take them. So that happened. I'm going to give you a quiz on Canvas. Quizzes are going to be multiple choice. You will have 1 shot at it. And the purpose of the quiz is to show you what material I expect you to be able to do. Okay? Quizzes are going to be problems that I come up with myself. Some people use Chegg to solve the homework problems. You can't use Chegg to solve my quiz problems. You can't. At least that's what I was told by somebody who used Chegg. So, all right, point breakdown. There you go. You can always look back on this. This document is posted on Canvas. Yep, I will give you your project guidelines when the project is announced. This first week, we're going to be talking about power, energy, voltage, current, and Kirchhoff's laws. We're going to have continued lectures today talking about that. We'll then be talking about resistive circuits. We're then going to be talking about soldering Raspberry Pi. I told you that was coming up. I'll give you some information this week. I'm going to post it on Canvas, and we'll probably talk about it on Thursday. But I am going to expect you to purchase a Raspberry Pi. Well, I'm going to hope that you will. It's going to make your class time a lot easier if you do. We'll talk about inductance, capacitance, RC, RL, RLC circuits. We do have some conversation on AC circuits. There is an exam I'm going to give you. And we will talk about some other select topics and circuits towards the end of the semester. It's broken up where the beginning of the semester is analog circuits, the last end of the semester is digital circuits. Pretty straightforward. I try to follow the book really well, and this shows you the chapter progression of how I follow the book. Okay. All right. There are other things on the syllabus. There are links to follow. If you need any accommodations, please let me know. I do my best to try to accommodate because I understand that learning is more of a challenge for some people than it is for others. And certainly a 2.5 hour long class is going to have a lot of problems. Okay, that was the fun part of this class, is going over introductory stuff and me telling you how hard this class is going to be. If you haven't peed yet, we're going to take a short break where you can go see a man about a wallaby. I know I'm going to. And I will be right back at about 8:35. I'm staring at my wrist. I'll see you in about 5 minutes for another lecture. Okay, this is where we're going to start jumping into the meat of the material, so I would make sure you have the ability to take notes. Again, all these videos are posted on YouTube. You can come back and watch them later. They're there. If you don't want to wake up at 8 o'clock in the morning and watch this video on Thursday, feel free to watch this later in the day. I'm posting them at 8 o'clock because I'm trying to force myself back into the routine of waking up and being here at 8 o'clock. I'll be okay.